Title of today's short lecture, PowerPoint presentation, is Frequency Distribution Tables. And in this presentation, we will cover what is a frequency distribution table, why are they useful. We will go over creating an ungrouped frequency distribution table with some data that I provide, and creating a grouped frequency distribution table. So what is a frequency distribution table? So if you go back to the beginning of the class and my corny acronym COPS, collecting data, organizing data, presenting data, and summarizing data, you can say a frequency distribution table is a great way to help us organize data. This allows us to manage a large amount of data and make it easier to interpret, understand, etc. So it's just an organizational tool, and it's really useful when we have large amounts of data. Okay. So here's an example where I give you some letter grades that I just made up. Just looking at the letter grades, it's difficult for me to see what kind of patterns are existing. And what if I add a little bit more data, it becomes even more difficult just to look at the data and see what's going on, what type of shape the data may assume, etc. And so I can take this data, and at the most fundamental basic, this is the most basic frequency distribution table that you can create, where it has the variable and the frequency of each level of that variable. So in this case, we had letter grades, A, B, C, D, and F. Since it's ordinal, place them in order. If we had nominal data, you could place them in any order that you wish. And the frequency of each, or the little italicized F being the symbol that we will use. And I've given you 100 pieces of data, so N is 100. So to me, this is a lot easier to look at, understand the distribution of my grades than the raw data. So it's a great way to organize, manage, help you understand the data that you have. So how do we create these? So let's start with an ungrouped frequency distribution. And we're calling it an ungrouped frequency distribution because we're not going to take the data that we have and group it. We're going to leave it alone. Typically, we're using data that has already been grouped. And so in this case, we have letter grades. And so we've taken all the 99s and 100s and 98s, et cetera, and put them in the A group. But we're not going to do anything further to the data, so we're going to call it an ungrouped frequency distribution table. In the next one, we will take some numerical data and actually group it before we organize it. So in this case, we're not going to do anything to further group the data that we have. Okay. So this is a more complete, if you will, I should say maybe more comprehensive frequency distribution table than this guy. This is at a minimum what you need. So in addition to frequency, I've added relative frequency, percent, cumulative frequency, and cumulative percent. You don't need all of these categories. Again, the point of a grouped or ungrouped frequency distribution table is to help you manage the data or help you to present the data to others in a way that makes the most sense to you and the reader. So you won't always need all of these categories. I've just presented them. You can actually have additional categories from what I've placed here. So we have our variable, letter grades, and this is the data that we started with. It's the same data set that I presented on the earlier slide. And so the first step is you have to figure out how many Fs, how many Ds, how many Cs, how many Bs, and how many As. If there's a mistake made with a frequency distribution table, it's just a simple mistake of miscounting. Now I made the data, so I know how many Fs, and As, and Bs, and so forth. So it turns out we had 10 As, we had 20 Bs, 40 Cs, 20 Ds, and 10 Fs. It rarely comes out that nice and neat, but I created it on purpose so it would come out that way. And when you count all these up, they have to equal 100 because our sample size was 100. If they don't, then you've made a mistake somewhere. Okay? Now, what is relative frequency? Relative frequency, all you have to do is take your frequency and divide it by n. So this is 10 divided by 100. This is 20 divided by 100. This is 40 divided by 100, and so forth. So I got 0.1 by taking 10 divided by my sample size of 100. I got 0.2 by taking 20 divided by 100. And 0.4 is 40 divided by 100. 20 divided by 100, and naturally 10 divided by 100 is 0.1. To get percent, all you have to do is take your relative frequency and multiply it by 100. Relative frequency and percent give you the same information. They just give you the same information in a different scale. So this is 0 to 1, this is 0 to 100. So to get percent, all you have to do is take your relative frequency and multiply it by 100. That's it. So you probably guess this is going to be 20, this is going to be 40, this is going to be 20, and this is going to be 10. So multiply this by 100, you got 20. Multiply this by 100, 40, and so forth. That's all there is to it. So in order to find percentage, you actually have to first find relative frequency, which is just frequency over n. Then you multiply by 100, you change the scale, you now have percent. Cumulative frequency and cumulative percent, these two will not always be present. In fact, sometimes it makes no sense to have them. In this case, it makes sense to put them. And the reason for that is we have ordinal data. We can put our data in a meaningful order. But if we had nominal data, there would be no meaningful order, and there would be no meaningful cumulative frequency or cumulative percent. So if you have nominal data, these two categories make no sense whatsoever. But we have at least ordinal data, so we can work our way up. So our cumulative frequency for the first one is simply all the F's, all the scores we have at or below the F, which is 10. The next cumulative frequency is going to be all the scores at or below the D level, which is the D's and the F's, which is 20 plus 10, and we know that's going to be 30. Then the cumulative frequency for C's is all the scores at or below the C level, no pun intended, and so that's going to give us 70, 40 plus 20 plus 10. And then cumulative frequency for the B's, all the scores at or below the B level, and we know that's going to add another 20, so the sum of these is 90. And then naturally, your total cumulative frequency has to equal your N, and so all the scores that we have at or below our highest score has to be 100. We're going to do the same thing to find cumulative percent. All we have to do is add our percentages. And so we have 10, 10 and 20 gives me 30, 10, 20, and 40 gives me 70, 10, 20, 40, 20 gives me 90, and then all of these together, cumulatively, it's got to be 100. That's it. How do we create a grouped frequency distribution? So the grouped frequency distribution is almost identical to the ungrouped frequency distribution. The difference is you have to make two decisions before you begin. And the first one is we have to figure out what our interval size is going to be. So in other words, how much or how little do we wish to group our data? And typically when you have a group frequency distribution table, you have numerical data. In this case, I provided ages of professors. So I just made up 20 scores here. And I decided to group them by interval size of 15. I could have grouped them by interval size 5. I could have grouped them by interval size 20. The decision is up to the researcher how they think it makes most sense to group the data that you have. So I just chose 15. It worked out pretty well. But there's no right or wrong way to come up with your interval size. Now, if you make your interval size too big, so if I made interval size of 40, I'd really only have two groups, and I would lose too much information. And if I decided to make my interval size maybe just 2, then I may not accomplish the grouping that I wished to achieve, and it might not make the data any more manageable. So I chose 15, which I think is reasonable. And the second thing you got to choose is, well, where do you want to start? So I could start at 0, go from 0 to 15 or 0 to 14, then 15 to 29. To me, I like to start at a interval that includes my lowest score. So if I look at my data, I believe the youngest professor that I made up was 29. So I wouldn't want to start at 30 because I would miss this person. And if I started at 5, I wouldn't capture this person with my data. So by starting at 25 and going up to 39, I capture my lowest score. And I'll start at a nice interval of 5, 40, 55, and 70. Again, that would be up to you to decide where you want to start, but I think this makes reasonable sense here. So again, same process. How many scores do I have between 25 and 39? And that's 5. Now don't make the mistake of putting 25 to 40, thinking, well, that's 15. If you do that, you've actually captured 16 scores. So it's always one less than you think. So it's not 40 to 55, it's 40 to 54, but it's including 54. So you actually have 15 numbers. And this is not 55 to 70, it's 55 to 69. That's 15 numbers. So it's, you think it, most students think, well, I need to go 25 to 40. And if you do that, you actually will have an interval of 16. So again, I'm just going to count. Again, I have an N of 20. So when I sum my frequencies, I have to come up with 20. So that gives me 9, 14, 18, 20. So that is 20. Now the process is exactly the same. Relative frequency, 5 over 20, 9 over 20, 4 over 20, and 2 over 20. So 5 over 20 is, sorry, I need to fix that, but it's 0.25, 0.45, 0.2, and 0.1. So if we go back, I made a typo. This should be 0.25, not 0.1. Same with percent. We know percent and relative frequency give you the same information, but they give you the same information in a different scale. So all I have to do is take this and multiply by 100, and that gives me 25. 45.45 times 100 is 45, 20, and 10. That's it. Cumulative frequency is going to be the same. I just add up my frequencies. So the first interval has a frequency of 5. So I've got to start with 5. 5 and 9, 14. 5, 9, and 4. It's got to be 18. And then all of them together, 18 plus 2 is 20. Same with cumulative percent. Start with 25. 25 and 45 is 70. 70 and 20 is 90. And 90 and 10 is 100. That's it. That's literally all you have to do to create a grouped or ungrouped frequency distribution. Let's do a few practice questions, see if it's sticking with you and making sense. So I've given you a basic, the minimal frequency distribution that is possible with the variable of interest and frequency. In this case, I've asked you, is n for the table below equal to 10? Well, to find your sample size, you just add up your frequencies. If I add these up, I do get 10, so it's true. My interval size for the table below, or I is 10 for the table below, but we know that's false because we only have an interval if we have a grouped frequency distribution. We don't have a grouped frequency distribution, so we don't really have an interval size. That's false. The table below is an example of grouped. False, it's ungrouped. Typically, grouped is going to be where you have numerical data and you've collapsed that numerical data to make a group of your choice. So this is an ungrouped frequency distribution, so it's false. The cumulative frequency for seniors. So here's my seniors, and we're just going to add up all the frequencies at or below. And we know that's going to be 9 because I've given you a sample size of 10. So 2, 4, 6, 6 and 2 is 8, 9. So that's true. The relative frequency for juniors is 4. So we know relative frequency is simply frequency over n. My n is 10, so that's 4 over 10 is 0.4, but not 4. So the relative frequency is 0.4, not 4. So that's why it's false. The frequency is 4, percentage is 40, but the relative frequency is 0.4. The relative frequency for sophomores is 0.2. So I come over and find sophomores. I see they have a frequency of 2. 2 divided by 10 is 0.2. That is true. The cumulative percent for juniors. So I come over here and find juniors. And so I know this would be 40%, 20%, and 10%. So we know it's not 30. The cumulative percent for sophomores would be 30 because this would give me 10% and 20%. The cumulative percent for juniors would be 70. That would give me a cumulative frequency of 7. 7 divided by 10 is 0.7, and then 0.7 times 100 to turn into percent would be 70. So false. The percent for seniors is 20. So my seniors, there's 2 of them. 2 over 10 times 100 is 20%. That is true. The interval for the table below is 4. That's false. It's actually 5. So we've got 1, 2, 3, 4, 5. So interval sizes will fool you. It always looks like it's 1 less than it should be. So in this case, it looks like it's an interval of 4, but it's actually an interval of 5. Includes 1, 2, 3, 4, and 5. This includes 6, 7, 8, 9, and 10. So I is 5. That's it. As always, you can call, text, email me 7 days a week, 9 a.m. to 9 p.m.